Hello folks, congratulations on completing your first chapter in online algebra. We're going to get started by jumping back into chapter 10, starting with 10.1, the Pythagorean Theorem. We're going to start with that to start thinking, what shapes have right angles? So think about the shapes that have 90-degree angles inside of them. And while you're drawing those down, I'm going to tell you a little bit about Pythagoras, the guy who found the Pythagorean Theorem. He's an ancient Greek philosopher, roughly 4,000, 5,000 years ago. And the biggest story I know about him is that he once had one of his students come and tell him that he disproved a part of mathematics Pythagoras fundamentally believed. So what did Pythagoras do? Well, he killed the guy. Thankfully, this theorem right here, Pythagorean theorem, has kept up for these 4,000 years, so hopefully nobody's getting killed. All right, start thinking. What shapes do we have that have right angles? Well, we know we have squares and rectangles. Right? And remember, we denote right angles by putting little squares in the corners. We could have a rectangle. But the one we're really going to be focusing on today is the triangle. So this is a right triangle, or at least it would be if I was drawing this properly. So a right triangle, we have specific names for each of the sides. The longest side we call the hypotenuse. So the hypotenuse is the longest side, and the two shorter sides are called legs. So we have legs and hypotenuses. And what Pythagorean's theorem says, let's actually write out what it says. It says if you have a right triangle, so we're going to draw this out and we're going to give the sides specific names. So we have a right triangle here, and we'll call the two legs A and B, and we'll call the hypotenuse C. And what it's saying is, in this right triangle, we know that A squared plus B squared is equal to C squared. Or think about this as the square of the two legs, so one leg squared plus the other leg squared, is equal to the square of the hypotenuse. Now this is actually really important and a really useful tool to have when we're going through a lot of the rest of math. So you're going to remember this one a lot. Let's get started with some examples of how we would use this. So we're going to try to find the hypotenuse for these. Have a couple of examples here. Let's start with this one. We'll say that these two sides are 6. Once again, my drawing skills are not super great here, so try to make those as even as possible. And we'll call this last side C. So how are we going to find this hypotenuse? Well, we know that 6 squared plus 6 squared, the sum of the two legs squared, will be equal to C squared. Or this is 36 plus 36 is equal to C squared. Or 72 is equal to C squared. Now what we're going to do to solve for C is we're going to throw that into our calculator, take the square root of that, and that will come out to be about 8.49. So we're going to change this into about 8.49. We're going to round everything to the hundredths, and so that would be our answer. That would be the length of this hypotenuse right up here. All right, let's try another one. Let's say you have C and you have 6 and 5. Well then, got to make sure this is a right triangle. This would become 5 squared plus 6 squared is equal to C squared. Or 25 plus 36 is equal to C squared, which is the same as saying 61 is equal to C squared. Put that into your calculator. You'll see that it's going to be about 7.82. Now, where would this come up in real life? Well, this comes up a lot when we're dealing with squares. Let's say you're trying to lay tile. And let's say each of your tiles are laid diagonally. And all of your sides or 4 feet, or 3 feet. What if we wanted to know the distance this way? Well, that would be the same thing as for problem 1, right? This would be c, and we'd say 3 squared plus 3 squared is equal to c squared, or 9 plus 9, or 18 is equal to c squared. Take the square root of that to find that our answer would be about 4.24 feet across each way. To 4 feet. Right. So we can use this to find the hypotenuse, the long side of one of these triangles, but we can also use this to find the other sides, or the legs. Let's look at how we would do that. Let's say we have this triangle here, and this side we'll say is 13 centimeters, and this side is 5 centimeters. If we're trying to solve for b here, what would we do? Well, we know that the two legs, so 5 squared plus the other leg, b squared, will be equal to the hypotenuse squared. Or this becomes 25 plus b squared is equal to 169. This gives us b squared is equal to 144. Take the square root of that and you find your last side is going to be 12. So this would be equal to 12. All right, so Pythagorean theorem, pretty simple. The squares of your sides, a squared plus b squared, will equal the square of your longest side. We can use it to find the hypotenuse, or the longest side. We can use it to find the legs. We have a couple more things to cover in here. The first is going to be what we call the converse of the Pythagorean theorem. I'm going to shorten Pythagorean theorem to PT here, because that's really long. And all a converse is it's effectively looking at the reverse of what we know. So the Pythagorean theorem says if we have a right triangle, the sides are going to be a squared plus b squared equals c squared. This is going to flip that. So this says if we have a triangle, and we're going to call the sides a, b, and c, and we know that a squared and b squared is equal to c squared, then the triangle is a right triangle. So this is just the flip of the Pythagorean theorem. If we have a triangle and the sides a squared plus b squared equals c squared, then we know that triangle has to be a right triangle. So let's take a look. Let's look at an example. Are these right triangles? If we had 10 inches, 24 inches, and 26 inches, would that be a right triangle? So we'd have to look at this. We'd say, well, is 10 squared plus 24 squared equal to 26 squared? So we pull out our calculators. We'd see that that's 100 plus 24 squared is 576. Is that equal to 26 squared? Or is that equal to 676? So 100 plus 576 does equal 676. This is a right triangle. Okay. What about if we had 8 feet, 15 feet, and 16 feet? How would we check if that was a right triangle? Well, we do the same thing. We'd put these into Pythagorean's theorem. Is 8 squared plus 15 squared equal to 16 squared? Well, 8 squared is going to be 64. 15 squared, if we put that in, is going to be 225. And 16 squared is 256. So 64 plus 225. We get that 289 is equal to 256. That is very much not true. So this could not be a right triangle. Right. That's all we have for the lesson. So let's get started on some practice. So again, it's important to make sure you're doing these before you go on to the homework. So here is our practice. We're going to have you find the missing side. We'll have two of these. Let's say you have, this is going to be C is unknown. We have a side that's 12 and a side that's 9. And then let's say you have something that looks like this. Say this is 25 and this is 24. What is A going to be? And then finally, our last problem. Let's say you want to lean a 10-foot ladder eight feet up a house. How far away should you put the ladder? This one's going to be tricky, so the hint I'm going to give you is you're going to want to draw a picture to see what this would look like. Right, so go ahead and do those, and we'll get started once you finish that. Okay, so welcome back. Let's do these. We have, for this one, we're trying to find C, so this becomes 9 squared plus 12 squared is equal to C squared, or 81 plus 144 is equal to C squared. If we combine those, this becomes, what would that be? 225 is equal to C squared. So we're going to take the square root of that to figure out what C is equal to. We find that C is going to be 15. For this one, we're trying to solve A. So that's not the long side. It goes on the other side. We get A squared plus 24 squared is equal to 25 squared. A squared plus 24 squared is 576, and 25 squared is 625. Subtract those, we get A squared is equal to 49. Take the square root of that, we know that A is equal to 7. Then finally, for this last one, now this is hard unless we draw that picture. So we have a 10-foot ladder. We're putting it up against an 8-foot wall. And we're going to have our ladder. Let's draw that as a ladder. We know the ladder is 10 feet tall. And we want to know how far we're going to place this away from the wall. So how far away do we need to place this to make it so that we're going to go just up to 8 feet? So we're placing it that far away, and look at that, we have ourselves a right triangle. So this becomes 8 squared plus x squared is equal to 10 squared. So we finish solving, we get x squared is going to be equal to 36. So we know we have to place the ladder 6 feet away to be able to just go up the 8 feet that we need. That's it for today's lesson. Key parts being that formula, right? So we have Pythagorean's theorem, which says a squared plus b squared equals c squared, right? We have a right triangle. The two legs, square the two legs, add them, and it'll be equal to the square of the hypotenuse. We can use that to solve for the hypotenuse or for the other sides, as well as some other things. So go ahead and go do the homework, and we will get started with the next lesson. We're going to be jumping to 10.6 for that.